we mastered the art of play to power the minds of tomorrow. That company is NVIDIA. Today, NVIDIA's technology sits inside the infrastructure used to train and run some of the world's most advanced AI systems. But NVIDIA's rise was anything but guaranteed. There were moments when the company was close to failure. There were products that didn't work. There were brutal shifts in the technology industry. And there was one enormous bet that changed everything. NVIDIA didn't built something AI desperately needed: massive computing power. This is the story of how a small Silicon Valley startup became an AI empire. In 1993, founded NVIDIA. Their original vision wasn't to dominate artificial intelligence. They wanted to transform computer graphics. At the time, personal computers were becoming more powerful, and the video game industry was entering a new era. Gamers wanted something that computers struggled to deliver: realistic three-dimensional graphics. NVIDIA believed specialized processors could handle graphics far more efficiently than traditional CPUs. But entering the semiconductor industry was incredibly risky. Developing chips required enormous amounts of money. One major mistake could destroy a young company.
And the company's first major chip architecture did not perform as expected. NVIDIA was forced to make difficult decisions and rethink its strategy. The company survived, and
in 1999, NVIDIA introduced the GeForce 256 graphics processing unit. The idea was simple but powerful. Instead of asking one processor to handle everything, specialized processors could perform enormous numbers of calculations simultaneously. For video games, this meant better graphics. But NVIDIA had unknowingly created something much bigger. The same type of parallel computing could also perform mathematical calculations useful for science. At the time, few people understood how important this would become. NVIDIA's GPU was designed for graphics, but underneath the graphics was a new computing architecture. And years later, AI researchers would realize this architecture was exactly what they needed. The next major turning point came in 2006. NVIDIA introduced CUDA. CUDA allowed developers to use NVIDIA GPUs. This was a critical strategic move. Suddenly, NVIDIA wasn't just selling graphics processors. It was buildings could program NVIDIA GPUs to perform complex calculations. Scientists could accelerate simulations. Universities could experiment with parallel computing. And AI researchers gained a powerful platform for machine learning. This was NVIDIA's hidden advantage. NVIDIA had planted a seed. It just didn't know how enormous the tree would become. Then machine learning began changing. Researchers started developing increasingly powerful neural networks. But these systems required enormous amounts of computation. Traditional CPUs were not ideal for performing the huge number of parallel mathematical operations involved. Calculations simultaneously gave researchers a practical way to use that power. Then came a historic moment. In 2012, researchers used GPUs to accelerate deep learning training. The results helped convince the tech industry that neural networks could become far more powerful than many people had expected. For NVIDIA, this was the beginning of a transformation in graphics. Now those same technologies were foundation of modern AI.
As AI research accelerated, NVIDIA began shifting its strategy. Graphics cards anymore. It was building completing platforms. Data centers became increasingly important.
Cloud companies began buying huge quantities of GPUs. Technology companies needed more computing power to train increasingly sophisticated AI models. Its hardware became faster. Its networking technology became more important. Its software ecosystem became deeper. That difference would eventually be worth hundreds of billions of dollars.
Then came the moment that changed the public's perception of AI. Generative AI exploded into mainstream attention. Chatbots could write, AI could generate images.
Models could summarize documents, create software, and answer complex questions. Suddenly, almost every major technology company wanted. But there was a problem. AI required enormous computing infrastructure. Training advanced models required thousands of powerful processors. Running those models for millions of users required even more. And one company was already positioned: NVIDIA. The company's GPUs became some of the most sought-after pieces of technology in the world. What began as a bet on graphics had become a bet on the future of computing. NVIDIA continued developing. Its Blackwell architecture represented another major step. NVIDIA increasingly designed complete systems: GPUs, CPUs, networking interconnects, software, and complete data center architectures. The goal was to create what NVIDIA increasingly describes as AI factories, enormous computing systems that take data and electricity as inputs, something increasingly valuable, intelligence. And the demand for these systems has been extraordinary.
The financial transformation tells the story. For fiscal 2026, NVIDIA reported $215 billion in revenue, up 65% from the previous year. Its
data center revenue alone reached $62.3 billion for the quarter. Then the momentum of fiscal 2027, NVIDIA reported us billions in revenue, an 85% increase from the same quarter a year earlier. These numbers reveal something important. NVIDIA was no longer primarily a gaming company. The center of gravity.
It began with a quest to perfect computer graphics. Today, it powers the world's AI infrastructure. NVIDIA, since its founding in 1993, his strategy has repeatedly involved making long-term technology bets before their full commercial potential was obvious. The GPU, CUDA, accelerated computing, AI data centers, and now complete AI infrastructure. This is one of the most important lessons from NVIDIA's story. The biggest technology opportunities don't always look obvious at the beginning. A product created for gaming became essential to AI. A programming platform and a semiconductor company became an infrastructure company. But NVIDIA isn't stopping with Blackwell. Platform, designed around the next generation of AI computing. The platform combines multiple chips and systems into a larger AI infrastructure. NVIDIA says the Rubin platform is designed to reduce inference costs dramatically compared with Blackwell. This matters because AI is changing. The next phase isn't only about training giant models. AI systems are increasingly expected to reason, respond, use tools, and operate continuously. That means inference, running AI after it has been trained, could become one of the biggest computing workloads in the world. NVIDIA wants to control the infrastructure powering that, but NVIDIA's empire isn't guaranteed to last forever. Competition is increasing. Major technology companies are developing their own AI chips. AMD and cloud companies are designing custom accelerators. And governments are increasingly treating advanced chips as strategic technology. Export restrictions can affect where.
Meanwhile, the AI industry itself faces a major question. How much money will companies continue spending on AI infrastructure? If AI demand keeps accelerating, NVIDIA.
But if customers eventually slow their spending, the company's enormous growth rates could face pressure. The higher a company climbs, the harder it becomes to keep growing at the same speed. In 1993, it was a small company pursuing 3D graphics. In 1999, it helped define the GPU. In 2000, then deep learning discovered the power of GPUs. And when generative AI exploded into the mainstream, NVIDIA was already building the infrastructure required to power it. That is why NVIDIA's rise is so unusual. It didn't suddenly appear because of ChatGPT. It spent decades preparing for a future that most people couldn't see. Today, the race is no longer simply about who makes the fastest computer. It's about who builds the machines that power artificial intelligence. NVIDIA wants to be at the center of that race, after maybe even bigger than the last. Because if AI truly becomes a new industry, NVIDIA isn't just selling the machines, it may be building the factories. This is Empire Decoded.